So we often use proportional reasoning to help us in our day-to-day lives. One of the things that we can use proportional reasoning for is when we're out shopping and we're trying to determine when things are a better buy. So if I want to compare some products, okay, I can compare their rates. So one store sells milk at 1 liter at 95 cents. Another store sells 2 liters at $1.85. Now, what do you think is going to be the better buy? And then think of why you think that's the case. Okay, and then what is the proportional reasoning that we can do to calculate and compare an equivalent quantity? Okay, so one of the things we could do is we could use a unit rate. So we have 1 liter for 95 cents. So we can write that as a unit rate of 95 cents per 1 liter. Okay, and then we can so that's that one there. And then we can compare this one here. We can find the unit rate for this, and we can say $1.85, so $1.85. So we're going to have to compare the same quantities. So we're going to do 185 cents compared to 2 liters, and we can compare that as a unit rate of 92.5 cents for 1 liter. Okay, so we can see that the 2 liters of milk for $1.85 is a better buy. So we could do it as unit rates. What we could also do is we could compare the 2 liter rates as well. So instead of 95 cents for 1 liter, I can times by 2 and use 190 cents for 2 liters. Okay, and then I can compare those two rates. Either way, we can see that the 2 liter milk is the better buy. Now I did this as a rate of cents per liter, but I could also flip that rate around and said liters per cent. And then I would be looking for the the bigger value, the more liters for the same number of cents or dollars would be the better buy. So here we have 5 kilograms of potatoes and we have it for $1.95. So I can do this as 5 kilograms for $1.95. And I can do an equivalent rate comparison by doing it to 10 kilograms. So comparing it to 10 kilograms to, and this is going to be times 2, so times 2 here is going to be $3.90. Okay, so when I do this kind of comparison, I can see that the 10 kilograms is going to be the better buy. Okay, so I could have done this as an equivalent rate of 10 kilograms. I could also do unit rates. Okay, so if I want to do a unit rate, I can find the unit rate. In this case, I'm going to do dollars per kilogram. Okay, so I'm going to find the unit rate in dollars per kilogram. So I'm going to take my $1.95, divide it by 5 kilograms, and I get 39 cents. Okay, so this ends up being 39 cents. Oops. 0.39 per 1 kilogram. Okay, so there's my unit rate. I can divide $3.25 by 10 kilograms. For here I get 0.325 or about 32.5 cents for 1 kilogram. So I can compare the unit rates. And again, in either case, we can see that the 10 kilograms is the better buy. So here we found we can compare the rates as equivalent, equivalent quantities. Here 2 liters to 2 liters, here 10 kilograms to 10 kilograms. We could also compare the unit rates. So we've calculated the unit rates here. So this is 95 cents. Okay, I'm going to just write it as 95 cents like that for 1 liter, and 92 cents, 92.5 cents for 1 liter. Okay, over here, when we talk about the unit rates, we can do the 1 kilogram rate. We could also do the $1 rate, but I'm just going to leave it as the 1 kilogram rate here. Actually, let's do the $1 rate. Okay, it's just so that we can do it both ways. So I'm going to divide 5 kilograms by $1.95, and so I get 2.56 kilograms. Okay, so 2.56 kilograms per dollar for $1. Okay, that's for that one, and then I can do 10 kilograms divided by $3.25, and I get 3.07. Okay, so I get I'm going to round that 3.08 kilograms for $1. So again, this works out to be a better deal because we get more for each dollar. So on Halloween, his older sister Jill takes Jack around the houses for trick or treat. They cover 15 houses in 30 minutes. How many houses will they get to in 2 hours? So their rate is going to be, we'll do a house rate, 15 houses for 30 minutes. Okay, and we can work out their rate for 2 hours. Okay, so that's going to be 120 minutes. Okay, so this is going to be an equivalent rate. So here we're going to use our times 4. We've got a times 4 going on here. So times 4, so that's going to be 60 houses in 120 minutes. So we can say 60 houses. Okay, so that's the correct answer. We did start using this times divide strategy though, and we should maybe think of how we can do that with a times divide strategy. So we can do this, and maybe we'll do the next one. Actually, we'll do the same one. Just make sure we're getting the same answer. So we can start with 2 hours, and here is my ratio, my rate. Okay, my rate is 15 houses in 30 minutes. Okay, so first of all, I want to convert this into minutes. And I know that 60 minutes is equal to 1 hour. So I can use this. This is a rate as well. And remember, my unit analysis we just need to keep track of the rates. And if I want to convert it into minutes, I do 1 hour on the bottom so that the hours cancel out, and 60 minutes on top. Now, most of you probably just say, well, I know that 2 hours is 60 minutes, but I'm just doing this to emphasize the point that any rate we can involve in this calculation, as long as we keep track of the rates. Here, we want to get rid of the minutes, and we have houses and minutes. So I'm going to use the rate on the bottom needs to go minutes. And why does the minutes go on the bottom? Because they need to cancel out the minutes units that are left here. Okay, times on top, divide on bottom, top and bottom will cancel out. So we have 15 houses here. So now when I do this, it's all times on top, divide on bottom. So I have 2 times 60 times 15 divided by 30. Okay, well 60 divided by 30 is going to be 2. 2 times 2 times 15 is 60 houses. So we get the exact same solution, but now we're using this unit rate, the unit analysis strategy. So let's do the same thing here. Let's use a unit analysis strategy here. So I'm going to start with 65 houses. Okay, and again, if I'm not sure about this strategy, I can always go back to my proportional equation strategy. But I have 65 houses here, and I have this rate 15 houses 30 minutes. Okay, well, I can put my houses in the denominator, 30 minutes in the numerator, and the houses and houses cancel out. 65 times 30 divided by 15. Well, I'm going to do 30 divided by 15 first, and I get 130. The units are going to be minutes. Okay, so if I can get 60 houses or 15 houses done in 30 minutes. 65 I need to do about times 4. Or in fact, we can look at this one here. We have 60 houses in 120 minutes. We just need a few more minutes to get the 5 extra houses. This problem could also be done as a unit rate. We know that we have 30 minutes for 15 houses. So my unit rate, this is separate here, my unit rate becomes 2 minutes per one house. 2 minutes per house. So if I have 65 houses, and notice that the unit rate, it becomes our multiplier. We can just time this by 2, and we can get our 130 houses that way. Okay, so there's various strategies here. One is our proportional equation. That's our go-to. That's the one we use if we ever get stuck. The vertical here is our unit rates, and those are our vertical multipliers, are our unit rates. We also have this unit analysis strategy where times on top divide on bottom, and we just can cancel out units. And it's all about just keeping track of the units. So we're now starting to develop some more strategies here, and we can choose whatever strategy we want. However, the most efficient is going to be the one that we want to make sure that we eventually learn is this multiplication strategy. Okay, but this proportional equation strategy is one that you need to be able to show me. You have to be able to show me that proportional equation, how to set it up, and where all the times and divide factors are. And then you can start relating those multiplying factors to our time strategy. We can also look at our unit rates and how does the unit rates relate to the times divide strategy in our proportional equation. Okay, because remember, our unit rate is when we divide, so we get our multiplier. Our vertical multiplier represents our unit rate, because we can do houses divided by 30 minutes. That gives us a unit rate, or we can do 30 minutes divided by 15 houses. That gives us the unit rate that we calculated down here. Okay, so this is our unit rate. Just going to put in brackets, unit rate. Okay, so these are all concepts that we want to have in mind and practice using so that we understand and get good at them as well.